Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.4, Problem 10. This is Section 2.4, Problem number 10. It says, find matrix A such that A times the matrix 0, 1 in the top row, 2, negative 1 in the bottom row equals the matrix 2, 1 in the top row, negative 1, 0 in the bottom row. And underneath it says, hint, let matrix A equal the matrix AB in the top row, CD in the bottom row, all in lowercase letters. And that's a good hint. So let's start off rewriting this problem where it's written A times matrix 0, 1 in the top, 2, negative 1 in the bottom. Let's write that matrix A in the format that the hint is given. So I'm going to write two matrices multiplied together, one of them being AB in the top row, CD in the second row, times the matrix from the problem, the second matrix after A, which is 0, 1 in the top row, 2, negative 1 in the bottom row, and that will equal the matrix that's given in the question after the equal sign, 2, 1 in the top row, negative 1, 0 in the bottom row. And we will work this problem out and try and find the values of lowercase a, lowercase b, lowercase c, lowercase d. So what we're doing is multiplying two matrices, and you can verify that these dimensions will work out. The first matrix is a 2 by 2, and the second matrix is also a 2 by 2. They each have 2 rows and 2 columns. The inner numbers do match, showing that the first matrix has the same number of columns as there are rows in the second matrix. The result should be a 2 by 2 from the outer little numbers that are given when you write the dimensions underneath. And the solution from our matrix equation here certainly is a 2 by 2. So this is something that will work out. Now, when we multiply this out, let me write our big boxes like I usually do in a 2 by 2 format. And what we're going to do is write some equations in these boxes, actually, and we'll use those equations to find the values of the variables a, b, c, and d. So I'm going to start with a matrix made with big empty boxes in a 2 by 2 format. And now I'm going to see what happens when I multiply the top row of the first matrix, AB, times the second row of the second matrix, 0, 2, or the first column of the second matrix, I meant to say. I'm going to multiply the top row of the first matrix times the first column of the second matrix. And I can see that the result I get has to be a 2. That's the value in the top row and first column of the solution. So now when I multiply first times first, I have A times 0 plus second times second will be B times 2. And that has to equal the value in the top row and first column of the solution, which is 2. So now when I simplify this equation a little bit, A times 0 from first times first is just 0. That can just be thrown away. So B times 2, I have 2B equals 2. So if I divide out the 2 in front, I'll see pretty quickly that B is equal to 1. So now there's one of my 4 answers. B is 1. So now let me multiply the top row of the first matrix, AB, times the second column of the second matrix, 1, negative 1. And it has to be equal to the value in the top row and second column of the solution, which is 1. So when I do first times first, I'm going to have A times 1 plus second times second, which is B times negative 1. And that has to be equal to the value in the top row, second column of the solution matrix, which is 1. So now as I simplify that a little bit, A times 1 from first times first is just A. A times 1 is A. Plus b times negative 1 is really 1 times negative 1, because I know from the previous box that the value for b has to be 1. So b times negative 1 is really 1 times negative 1. So it's really a minus 1 equals 1. So from that, I can figure out that a has to be 2. If a is 2, 2 minus 1 would make the equation 1 equals 1. Or you could just add the 1 to both sides of the equation, and you'll see that a is 2. So now I have 2 of my variables solved. So now, as I do some of the work in my lower boxes of my solution, I'm going to take the bottom row of the first matrix, which is CD, and multiply it times the first column of my second matrix, 0, 2. And that answer has to give me the value in the bottom row and first column of my solution, which is negative 1. So that's going to give me another equation. So the bottom row CD times the first column of the second matrix, 0, 2. So first times first, I'm going to have C times 0. So C times 0 plus second times second will be D times 2 equals the value in the bottom row and first column of the solution matrix, which is negative 1. Now, as I start working on that, the first times first, C times 0 is 0. So again, I can just ignore that. And I'm left with D times 2 equals negative 1. So D times 2, I would prefer to write 2D equals negative 1. And if I divide out the 2 to solve for D, what I get is D is negative 1/2. And now I have one more box to fill in. So I'm going to do the bottom row of the first matrix, CD, times the second column of the second matrix, 1, negative 1, has to give me the value in the bottom row and second column of the solution matrix, which is 0. And it's going to set up another equation for me that I can solve. So first times first will be C times 1. Plus second times second. So the second is D times the second here is negative 1. So second times second is D times negative 1 equals the value in the bottom row and second column of the solution matrix, which is 0. So that gives me another equation, which I can simplify a little bit. First times first, C times 1 is just really C. And then D times negative 1 is really minus D. And that's equal to 0. So if C minus D equals 0, let me just pull the D on the other side of the equation. So I'll have that C equals D. And now if I know that D is negative 1/2, and C equals D, then C is also negative 1/2. So now I have the values for all those variables. So the hint, going back to the original question, said let A equal the matrix A, B, C, D. And now that I know what A, B, C, and D are, I can see that the final answer is A is the matrix. So the variable A has a value of 2. And then next is B. The variable B has a value of 1. And then in the bottom row, C and D, they both have a value of negative 1/2. So the matrix A that would make the original equation in the problem true is the matrix with 2, 1 in the top row and negative 1/2 in the bottom row.